Hi everybody. So for today's lesson, Unit 6, Lesson 4, Solving Equations Involving Logarithms, we're going to go through the lesson using this video. So what we'd like you to have out right now is your notes for Lesson 4, so you can access them in the today's task on Canvas, which is where you also would have found this video, or the packet is in the modules for Unit 6. What we would like you to do after watching the video, we'd like you to complete your notes while watching it. You are going to submit your notes to us on Canvas just so we know that you watched the video and completed the lesson. And then there is a practice and a homework, which are both optional additional practice for you after you complete the video. So after you complete this, probably 10 to 15 minute video, we would like you to then decide if you need a little more practice. There's practice questions, there are practice homework questions, both of which are not mandatory, but the answer keys will be posted on Canvas. You can use them just as additional practice. You will not have to submit homework for, you will not have to, submit the practice questions for lesson 4. So what we would like you to now start is the warm-up for this lesson. There are 5 equations we're going to have you solve, and each of them is going to be completed by converting the logarithm form into exponential form. So you're going to start using the loop trick, and then you're going to solve for x. Each of these will turn into a review equation once you've used the loop trick. I'd like you to pause the video and spend a couple of minutes working on these 5 equations. And then once you've tried each one, press play and we'll go over them together. Okay, so for equation number 1, we're going to use the loop trick. We're going to circle the base of 3. Circle the base, run the race, we end up with an equation of 3 to the x is equal to 27. So now I need to think of how to write 27 with a base of 3. So 27 is equal to 3 to the 3rd power. So now I can rewrite the right side of my equation as 3 to the 3rd. Now that I have this common base of 3, I know that their exponents are equal, so I now know x is equal to 3. What you also could do to check this, you started out with a log base 3 of 27. This is a logarithm that's completely numerical. If you now wanted to check this, go and type that into your calculator. Remember, it's alpha, that is not how you spell alpha, Miss Carnes. Alpha, window, choice 5 is log base. Or if that's disabled in your calculator, you can do a common log of 27 divided by a common log of 3. Either way, you would see that this is equal to 3. And we'll review that a little bit later in the lesson anyway. Okay, let's try number 2. We're going to circle the base of 4, run the race. For this one, we get 4 to the x is equal to 1 over 64. So let's just think about the comparison between 64 and 4. If you wanted to just rewrite the number 64 with a base of 4, it would be 4 to the 3rd. Since it's 1 over 64, I would rewrite that as 1 over 4 to the 3rd, but I want a base of 4, not a denominator of 4. So then I would bring that 4 out of the denominator using a negative exponent. So this is going to become 4 to the negative 3rd. Now we have common bases of 4, so we know x is equal to negative 3. Okay, on to number 3. Now 3, similar to 1 and 2 because x is equal to the logarithm, so it is going to end up as our exponent. However, my logarithm doesn't have a base indicated. So this is a common logarithm, base 10. We're going to circle the base, so we want to write that in because if we don't write that in and we're converting forms, we don't really know what we're circling and what we're making the base of our exponential equation. So now if I want to go backwards here, it's almost thinking scientific notation backwards. So how did I get to this number? I moved my decimal place 4 places to the left. So this would be 10 to the negative 4th power is equal to 10 to the x. Now that I have base 10, I know x is equal to negative 4. And again, all of these, the first 3 questions, you could type the logarithm in the original left side of the equation and confirm that it equals these values. Okay, now 4 and 5, we're still going to approach them the same way initially, but if you notice now, x is either in the logarithm as the base or the input. So these are just going to look a little different once we convert out of these forms. So when we go into exponential form for number 4, this one's really nice. I don't have any common bases to worry about. I don't have an exponential equation because x is not in the exponent. I just have to square 3 and get 9, and I'm done. So number 4 was really nice. But number 4, you could not have checked the logarithm or typed it in initially to know your answer because the logarithm was missing a value. So now what you could do if you wanted to check this, you could type in log base 3 of 9 to see if that indeed equals 2, and it will. Okay, and let's try the last one here. Circle the base of x, circle the base, run the race. So for this one, we have x to the 2/3 power is equal to 81. Now, this is not something I can just simply type in like 3 squared or use common bases. It's not an exponential function. It's actually a function where we have a rational exponent. So we solved these last unit as well, and we raised both sides to the reciprocal power to solve for them because we want to get x to the first power. In order to do that, I need to use the reciprocal of 2/3, which is 3/2. Now, because this has an even denominator, we know when the denominator is even, that means it has an even root, which means we need a plus or minus. Now, the 3 was the power, so now let's think about what this really means. This is the square root of 81, that's the root, that's why we needed the plus or minus, being cubed. So when I go to look at this, this would become plus or minus 9 raised to the third, so I'm going to get a positive and a negative 729. And that's what 9 to the third would be. And again, if you went back to the original, you could look at this and you could actually make the base either of these. You're going to get an error on the negative, so let's actually take this one step further. We don't really solve logarithmic equations in this course, but we'd actually have to amend this a bit. The negative, and again, this is going a little bit beyond our course, the negative would have to be rejected because if we remember the domain of logarithms, the domain has to be greater than 0. So you actually can't have a negative value in the domain of a logarithm, which means it could not be a value for its base or for the input. So again, that part's going a little beyond our course. If you understand how we got to the 729, then that's what you really would need. Okay, so now let's take a moment to see what we're doing today. So we're solving equations that we're going to be using logarithms, but we're not solving equations that start out as logarithmic equations like the ones we were just working on. We're going to be solving exponential equations like we did last unit, but we're not going to be using the method of common bases. We're going to be using logarithms because the method of common bases only works when you're able to come up with a common base. And more times than not, you're not going to be able to come up with one. So the steps are going to be, if the base is not isolated, meaning the number being raised to that power with x in it, you need to do that first. So isolate the base. Then we're going to convert the other way. We're going to go from exponential form to logarithmic form using the loop trick, the same thing we just practiced in the warm-up. And then we're going to actually evaluate the logarithm. So we're going to end up typing it into our calculator, getting a value for x. In this case, we're going to round values to the nearest hundredth. So let's try this new way of solving exponential equations. So for number 1, we have 9 to the x is equal to 14. Let's circle the base of 9, circle the base, run the race. Now we get logarithm base 9 of 14 is equal to x. So when you type in a logarithm like this, not base 10, not base e, but a logarithm with another base than the common or natural logs, we've been using alpha window 5. Just going to write that here. So in our calculator, we go to the alpha button, then the window button, then choice 5 is log base. Now, I know some of us still have this disabled, so I'm going to go over this, but then I'm going to show you the workaround. So there's another way you can type this in that's equivalent. So alpha window, go down to the 5th choice. We have, in this case, a base of 9, an input of 14, hit enter. We get approximately 1.20 if we're rounding to the nearest hundredth. Now, if the only thing you're unable to do is type this in, the log base, there's still a way to do this. So take your log base 9 of 14 and come down one more step, and you're going to convert this into just another way of writing this, which is using the change of base formula. So change of base, which says you can take any base logarithm. We're going to use a logarithm that we know how to type in because we don't need a special key for it. So we're going to use the common log, which is base 10. And you can take that same log and in the numerator, put the original input, which was the 14. And in the denominator, put the base, which was 9. And this is going to give you that same value. And I'll show you in the calculator now. So we had, I don't know why this one doesn't save what I typed in. Sorry guys, this one's a little glitchy, this calculator. So this is what we had before. And now if I use a common log of 14, close parenthesis, divided by a common log of 9, change of base shows me I didn't need that special alpha window choice 5. I can type it in with a common log. I just have to separate it between the log of the input divided by the log of the base, but I'll get to the same answer. You can also use this if, let's say, you're graphing a logarithm with a base other than 10 or e. Type it in using the change of base formula, and then you don't really need that alpha window option open on your calculator. So we'll check that again as we go through, just so we can practice both and that we're comfortable if our calculator maybe isn't allowing us to use the log base. So for number 2, we have to first isolate our base of 5. Now that it's isolated, use the loop trick. We're going to convert log base 5 of 18 equals x, or, again, I'm just going to write it here so you have the option. Common log of 18 divided by common log of 5 will also get you x. Okay, so alpha window 5, log base 5 of 18, or common log, you actually could do the natural log, I'll even show you that. Common log of 18 divided by the common log of 5. The change of base just says it has to be the same base, so it does not matter which base it is as long as it's the same and you have the input divided by the base in terms of the logarithm's input. So you can see here I use the common log, I use the natural log. Obviously we're doing this so that we don't have to use a log base application in our calculator, so these would be the two you'd be deciding between because these are the two that are just on the home part of your calculator. But in any case, you can see all three of these answers equal the same thing, which to the nearest hundredth would be 1.80. Let's get back here. So x equals 1.80. Okay, let's try number 3. So for number 3, we have 2 to the power of 2x minus 1 is equal to 15. So this base of 2 is already isolated, so we're going to circle it. Circle the base, run the race here. Now, when we get into log form, we don't have x alone. So what we could do is we could type log base 2 of 15 in now and get a decimal. We just don't want to round until the end. So instead, I'm just going to kind of show what we're going to do to this number once we're done isolating x. So I would add 1 to it. Right, so add 1 to the other side, and then I would divide the whole thing by 2. Again, this is just because I don't need to really type this in until I'm ready to know what x is. So now let's go to the calculator. Log base 2 of 15, alpha window 5, log base 2 of 15. It's going to give me approximately 3.906, but again, I don't want to round yet. I'm taking this logarithm, I'm adding 1, and then I'm dividing by 2. So we get 2.45. And again, if the log base is not working for you, you would do log of 15 divided by log of 2, or natural log of 15 divided by natural log of 2. And then again, you would add 1, divide by 2. 2.45. Okay, last question. So for this question, this was a Regents question, multiple choice. So let's not look at the choices. Let's just look at this equation and we're going to try to solve it. So in this case, the base is the 2, not this 8. So I'm going to divide both sides by 8. I want to isolate my base first. This is going to become 2 to the power of x plus 3 is equal to 6. Now I'm going to circle the base, run the race. So I get log base 2 of 6 is equal to x plus 3. And then just like I did in the last question, I'm going to isolate x before I would even like think about typing this in. And I get x by itself. So let's look at our choices here, because this question's interesting because they didn't actually write it out like this, but we didn't do anything wrong. So we just have to decide which one makes the most sense to match our answer. So we've been talking a lot in this lesson about maybe not having the option of using log base. So if we didn't, one way we know to rewrite this would be common log 6 divided by common log 2, and then we could do the minus 3 equals x. Now that's not a choice either, but look what is a choice. If you look at choice 1, they didn't use the change of base formula with the common log. They actually used it with the natural log, which we showed earlier in the calculator. That's the same thing. As long as these two logs are the same log, then this change of base formula works. So whether it's log 6 divided by log 2 or natural log 6 divided by natural log 2, either of them would be equivalent to the log with the base written in it. So log base 2 of 6. They're both equivalent to that format. So it is choice 1. Now, if you weren't sure about that, you'd go into your calculator, you would type log base 2 of 6 minus 3, which some of you might be typing in using the log change of base formula anyway, so then you might even be more familiar with typing it in this way. And then you would get your answer after you subtract 3, so we have negative 0.41, and then you would be looking probably at your choices to say, okay, well, which of these is equivalent to this? If you type in the natural log of 6 divided by the natural log of 2 and then subtract 3, you're going to get that answer. And then if now we know it's not equal to 0, and if you typed in the other two choices with logarithms then subtracting 3, you're not going to get that negative 0.141 value, and that would also be a way you can narrow down your choices if you weren't as comfortable recognizing the change of base formula in the problem. So I hope this video was helpful. At any point, if you want to go back, rewind, go through a few of the questions again, please do. We are going to have extra help Thursday morning this week, so please come by and attend if you have any questions on this lesson. But like I said, the practice questions that are in the next part of the packet, the answers to these questions will be posted online later today. And if you take a look at homework 6.4, the answers to that will also be posted. So you don't have to do homework 6.4, you don't have to do the practice questions to be submitted to us, but if you want to ask any questions about them or ask any questions about this lesson in tomorrow's class at the beginning, please don't hesitate to do that. And if you have additional questions that don't get answered tomorrow, then please feel free to stop by Extra Help on Thursday, and we'd be happy to go over that with you guys. I hope you enjoyed your snow day. I hope you're enjoying your kind of second partial one today, and we'll see everybody tomorrow.